Good morning. I am going to walk you through a quick but thorough creation of the plate, which we did part of in class last time, and I will do quickly in class with the rod and possibly the guide this week. But I wanted to give you a more thorough explanation of the plate. So here we go. Here's what it will look like when we're done. I also have gone into the book and found page 2-18, which is explaining the difference in selection of your sketch plane. I want to make sure that people understand the importance of selecting the proper plane on which to create your sketch, because if you look at the 2D profile down here that has been drawn, it is this shape right here is the same sketch drawn on, here's the front plane. These are shown in isometric view, which is something we can easily do using SolidWorks, and it's a common practice to display a part in isometric. So if you show your part in isometric, this is what it will look like when you draw on the front plane. This is what it looks like when you draw on the top plane. And right here's the top plane. So you're looking at it from this view. And then here is the right plane. So you're looking at it from this view, and it's the same sketch drawn on all of these, but when you show them in isometric, because of the selection of the plane that you chose to draw on, you end up with a different part, same part, just different orientation. So I want to stress the importance of proper orientation of your parts. Think of it as this is your car, like your car with your headlights here, okay, and the windshield here. Your car is sitting upright, right? It's sitting the way it's supposed to, properly oriented. Here, it's sitting on the tail and the headlights are pointing up. Here, it's facing sideways in your garage. If this is the way that you would drive to get out, it's the orientation is important, okay? All right. And then the other thing I wanted to mention was over here on page 20 and 21, we're talking about first and third angle projection. And if we zoom in a little bit here and look at the drawing, right here is the spot where the projection is shown, okay? And that is with the circle on the left. So it's like we're looking at the front view and here's the right view. And this is the third view projection, third angle, so third angle projection. And the other option is first angle projection, and those are used in different parts of the world. We use the third angle projection here where we have our front view, the right view is off to the right, the left is off to the left, and so forth, top and bottom. So this is the isometric, and it's like we're looking at it from this angle here, and that being the front. Okay, and when we use that in the United States and Canada. Over in mainly in Europe and Asia is where they use the first angle projection, and that has, here's your front view, and it's like they're looking at it from the back, I believe. Anyway, their left view goes over here, their right view goes over here, and the bottom goes up and the top goes down. And anyway, that is first angle. So first and third, we use third here in America, and here is the difference kind of shown here. But anyway, enough about that. Let's create a model. I'm going to create the plate real quickly, and to do that, I need to be in SolidWorks. So here we go. That's what it's going to look like when we're done. I've saved that as an example part. So let's make our own. We're going to do this starting on page 2-15, step 39, where we create a new part like this. We will use the part millimeter ANSI that we created. Part millimeter ANSI. Okay. And I want to make sure, as they show it in the book, there are no decimals. So I want to make sure that we are doing that with no decimals. So we go to document properties, to units there, and then the length, we want to take away the decimals. So we go up to none and say okay. And we're in millimeters. Okay. Usually what we'll do is we'll save the file first so that we can set up the name and everything. So I'm going to save as. I'm going to put this in documents, spring, semester, and projects. So I have a file in here called plate example. We will just call this plate. Oops. Plate, and then the description, which is what will show up in the drawing, in the bill of materials, we will call this plate 56 millimeter by 22 millimeter. Saving it in the project folder and save. Okay, up here on the top, it shows us the name of the file. And that is right up here. It says plate. Okay. And we are off to page front plane, off to page 2-22. Now I'm going to right click on front plane. And what I have here, right here, is what we call a context toolbar. Now that comes up in the context of where we have clicked with our mouse. So it's related to the features that we're selecting on and so forth. So that gives us an option here to create a sketch. I want to create a sketch on the front plane. So I do that by starting that sketch. Now the book tells us to, on step 49, it says to use a corner rectangle, but the rest of the pictures of the plate show it being a center rectangle. So I will choose the center rectangle, and then instead of starting on the origin like they do, I will start up here because that's the center of my rectangle. I will left mouse click and then come down here until the little orange dot appears on the origin. I will left mouse click on that. They tell us to right mouse click and then go to select, which should deselect the feature that you are in. For whatever reason, that does not function like that on my laptop, so I will just press escape to get out of that feature. Now I have black lines which are fully defined, blue lines which are not. So I will add a couple of dimensions. We see, if we come up to view, hide show, and then scroll down to sketch relations and turn that off, those little green boxes will appear or disappear. And those are telling me that those lines are horizontal or vertical. Horizontal or vertical. This is coincident with the origin, which is the red arrows. And then these two lines are coincident with the center, with each other, with the midpoint. So anyway, I don't want to have those in my view because they're kind of distracting, but I can see it's a good way to tell what relations are actually applied to those lines. So I'm going back up to up here to view, down to hide show, and then down to sketch relations. And when I originally came in here, I came to view, hide show, and this is what I saw. I didn't see any show relations, but there's a little black arrow at the bottom. So I go and click on that or just hover on it and it will scroll down to the very bottom. When it turns gray, you know there's no longer anything below that. So I turned off the sketch relations. Now I can define the dimensions and have a fully defined sketch. So I will come over here to Smart Dimension, left click on that. I will select the bottom line. We do the 56 first. We'll click on that. Left mouse click, slide down, left click again. And I want to make that 56 millimeters. And I know I'm in millimeters because down here in the bottom right corner, I have a box that says MMGS, right? Down there. So I want to say 56, hit the green check mark, there it is. I want this to be 22. Well, right now it's 40, now it's 22. And that is the shape of the box I want. And when I click on here, another name, another option that we have, or I can change the dimension right here. And this is in the modify box. Let's say, they call it a modify dialog box. That's step 61. They call it that. All right. Now we have our 22 and our 56 millimeter dimensions. One thing that we can do with our dimensions is there's a little dot right here, a little blue dot on the arrow. If you click on that, it will flip the direction of the arrows. So sometimes you want to have them inside, sometimes outside, depending on the space that you have available. That's more used in drawing because in sketches it doesn't make a big difference. Although when you're in a sketch and you pull your dimension and place it out here or over here, wherever you put it is where it will be when you pull it into your drawing. When you display annotations in your drawing, you can import the dimensions from your sketches. So where you place the dimensions in your sketch is important. It can save you time when you're creating your drawing. So that falls into design intent, which is design intent. If you have an idea of what kind of changes will be made in your part down the road, you can put intelligent design into your model and your sketches so that it makes it easier as you're changing things in the future. So anyway, design intent is something we will talk about throughout this course. So there is our 22. Here is our 56. If you notice on page 2-27, let's see, we can go 21, 22, 23, 24. Okay, sometimes the book will have misprints in it. I will try and inform you of these. Here is the correct dimension. Right here is 56. That's what we want. This is what we do not want, 55. But that's what the book is showing, but we want it to be 56. So disregard this, disregard that 55 and actually make it a 56, right? So 56 is the correct dimension. And step 71 and 72, they have us changing this. We are learning how to modify dimensions. So there is a dimension 22. I want to change that to 42, just like that. I can double click on it. The box turns blue. I can change it. There is another, I'll just show you now. There is a dial at the bottom here. You may not have noticed. And if you left click and hold on this, you can scroll it up and down, which is helpful because you can say, well, I want my part to look like this. No, I think I want it a little bit bigger. What's a better dimension? Yeah, that's I like that. That's about good there. Okay, so what is that? Oh, that's 80. Okay, so I want that dimension to be 80. It allows you to kind of shape and mold your sketch as you're going. You can also do that with the arrow buttons, or you can just type it in, which we will do because we know 22 is what we want. So there's our 22 by 56. And let's, we see now that all of the lines are blue, and right down here it says fully defined, right there. So we know our sketch is fully defined. That is the end goal of creating a sketch. The little stoplight up on the feature manager tool icon, stoplight means a change has been made. So we want to rebuild it. So to do that, we click on the rebuild button up here. And now it's gray. We're out of the sketch. It's fully defined because there's no dashes in the feature tree. What does it look like if it is not fully defined? If I get rid of that dimension, now there's a little bitty right here. So it looks like a TIE fighter from Star Wars. Looks like this. Oops. It's like that with a little dash in the middle and then another parenthesis. That we do not want. So just say no to not defined sketches, right? So we want a fully defined sketch. So to do that, we will put our 2 back in there. Now it's fully defined. It's the end goal so that we can have design intent. And we'll keep going. Now we are complete with the sketch. We're going to add some 3-dimension to our project here. We'll do an extrude. We want this to be 10 millimeters, and I'm looking at the direction. I want it to go back, so I will click on the arrows. You can also drag like this if you like, and it will tell you along this scale, it'll stop and click at various points. The intensity or the size of those stops can be determined in your properties. But again, we will just type in 10 because we know that's what we want. Click enter and the green check mark. Now we have our 10 millimeter part. Well, you know, the customer called us and said they don't want it to be 10, they really want it to be 5. So we get good at changing things. That happens a lot as you work on a project. So now I'm on page 2-31, and we are going to double click here to show the dimensions. Now I'm coming to the 10. I will click once. We'll double click. Now I'm putting in 5. We'll check the green check mark. And now it's 5. I will press the space bar, choose the isometric view. And because it's isometric, it's in this orientation. That's good. That's how we want it to be. Now I'm going to rebuild. I'm done with that dimension. By clicking the rebuild, it will change the model from being 10 millimeters deep to being 5 millimeters deep. And I want to change the name of my feature. Okay, step 90. I want to right click here. I can go down in my feature tree to where it says rename tree item right here. And I will do that. I will rename the tree item, and I want it to be called step 91. It says base extrude. And it's always easiest if you rename your features while you're doing them, because then you know what they are. You don't have to go back and figure it out later. And you can see what they are named while you're continuing to model your part, which makes it easier. Time to save. It's good to save often because sometimes SolidWorks crashes and you lose your work and you get to do it again. It's always easier the second time, but it still takes more time. So now we saved our part. Let's go and look at page 2-34. The display modes and the view modes remain active until you change them or until they're deactivated. The display mode here is the view orientation. So the display mode is a view orientation that tells us from what angle we're looking at the part, right? You can look at it from the front and so on, different, whatever. Front, side, top, and then the display display style, they call it. We have choices. We can look at it in a wireframe, which is, all of these have a particular reason. This allows you to select edges and see what's going on, all the faces at once. Here is the hidden view line shown. Here's hidden lines removed. Here is shaded without edges, and here is shaded with edges. And when you have large parts with lots of detail, it may be easier to, it may take less processing time to show it without the edges, but for clarity's sake, if you want to understand it more clearly, I guess, you can show it with the lines. I like to use with the lines because it shows the definition better. Now we're going to create some holes in our part. We will do this by going on to page 2-26. We'll position the mouse on the front face. Here, pick my sketch from the in context toolbar. This is sketch and this is edit sketch. So I'm going to create a sketch. And we're putting holes on here. So let's go normal to the face that we are working on. In my sketch, I will put a hole here, like so. There's my circle. Now I want to create another circle. So I'll pick the center point and hold down the control button. Now I will hold down my mouse and drag, and I need to pick the circumference. So I will pick the circumference of that circle, hold down Control and drag it. And now I have another circle. So that's a quick and easy way to create a duplicate circle. Now I want to make them horizontal, so I will pick the center points. And what just happened was over here on the left side, I have available some relations I can add to those two circles. I can make them horizontal, vertical. Coincident is where they are in the same spot. They're together or touching. I have the center points I selected. So if I make those coincident, it will put them both in the same spot and the circles will be overlapping each other. What I want to do is make them horizontal. Another thing I wanted to show you was if I pick here and now I hold down Control and I pick this, I have my in context toolbar pops up here where it's available to use, but if I don't go to it and I go somewhere else on my screen, it disappears. I can still do those features, but I need to go and find them. So I would have to go to, let's see, I don't know. I usually find I just do them there because it saves mouse movements. But you can, so yeah, I go here instead of going over to the left side where the horizontal is, because the fewer movements you need to make, the better. But if you do move and then you decide you want to do it, you can still find them over here. So those are now horizontal to each other. I want to make them equal. So select one, hold down Control, select the other, go to your in context toolbar, make them equal. Now I want to add a dimension. I want those to be I made them equal. I made them horizontal and I want them to be 4 millimeters. So I click the edge, drag it off the part so it will show in my drawing. It will show up over here instead of on the part. And 4 millimeters. Now I'm going to give them some location. So I will click the bottom line and the center. Come over here and I want that to be 11. And from this center point to this edge, I want to be 16.5. As you may have noticed while I was clicking on those, oh, okay. The other hole is going to be 39.5. And now it's a good time to go back to our 2 decimal places with our millimeters. Now that we need to show a 39.5 instead of 40. So to do that, I could go up to options, or I can come down here to MMGS and I can go edit document units. Now I come to length, click here, the drop down, and select 2 decimals and say okay. Now it should show me my decimals. And there they are, 39.5 and 11.00. How did I do that again? I came to down here and I clicked on the edit document units. And that took me to that's a shortcut to get to the document properties. Where then I came to length, and I came over here, clicked on the drop down and chose how many I wanted. Okay. So we have our sketch going with our 16 What happened here? Oh, look, somehow I ended up in inches. I want to go back to millimeters. There we go, 1650 and 3950. And that is shown on page 2-39 on the top. Now I'm going to, I'm fully defined, you can see. So I want to cut a hole there. I will go to features, extrude cut. And this will be going in the direction of the arrow through the part. The yellow dots are actually, and because it's blind, it's going 10 millimeters. What happens if I change my part to be 15 millimeters thick? It will only cut 10. So I want to, instead of have it blind, I will go through all. Now, if I change the thickness of my part to 25, now it will still cut through the whole part, right? Whereas if it was only cutting 10, it would not. So I will hit undo to get back to my 5. All right, I will go to isometric. And that was my through cut, got us through page 2-39. Now let's save it again. Save my file. And we need to change the name from cut extrude to mounting holes. Another way that we can do that, so we do that by, you can left click slowly twice. First time we did it, we right clicked and we came down to rename tree item. That's one way. The other way is to click and then click again. If you do it a little bit slowly, you can get the name to come up like that. If you do it quickly twice, it will just show the dimensions of the part. So click and click, and I wanted to call that shaded. No, I want that to be mounting holes. Step 172. And save. Let's put some fillets. Well, what have we done so far? Review the extruded boss base and extruded cut. Oops. Nope, we don't need news. So we created our part to, let's see, we can roll up and show just the part, just the steps as we did them. There's our base part that we did with a sketch. Created our sketch, and then we did the base extrude, and then to that we drew a sketch with some holes, with some circles, and then we did an extrude cut to put the holes all the way through, and we did that using the through all option rather than a blind depth, so that it would always go completely through the part. Now we're going to put on some fillets and some, I'll show you how to do fillets and the hole wizard. So to put a fillet on your part, what is a fillet? A fillet is a radius on an edge. So that is a good thing because it keeps the edges from being sharp. If we were making this from, oh, I don't know, making this out of grass or out of cork, it would not be a danger. If we were using glass or metal, it could be sharp if it was a sharp corner. And we oftentimes in industry will radius the corners because it makes it safer for the customer and for the people in our assembly who are putting the parts together. We don't want them to be injured because then it takes them longer to make the parts, to assemble the parts. So we'll put on a fillet. The fillet is located up here. Right here is the fillet, and there's a little black box. Anybody remember what you can do with, or the little black arrow? If you click that, it gives you choices, a fillet and a chamfer. Fillet is round, a chamfer is angled. So we're doing a fillet this time. I will choose manual. This is the constant fillet, and I want it to be, I'll scroll down here, and I want this to be 1 millimeter. So I will go 1 millimeter. Now, if I come up here and I click the top left edge, and I want to say multi, oops, follow the steps, Dave. Constant size fillet, 1 millimeter, click the top left corner, select the connected to start loop 3 edges. Okay, let's back up a second here. It's nice to have in context menus pop up, but it's also easy to miss them. So we have 1 millimeter, we have tangent propagation. Let's come over here and click this, and look, something popped up. And this is the connected to start loop 3 edges. I want to pick that. So as I hover over these, what shows up as pink edges in my graphics area is telling me what will be filleted if I choose this option. So this will fillet all the edges. This will fillet, says internal to feature, 11 edges. I want this one with the 3 edges. Because of the method I'm using, I will get this done in a couple steps instead of many. So I have, by clicking that one and the one edge, and then picking the drop down or the in context box here, that selected the other 3 for me. This shows how many edges will be filleted. They show up as highlighted in my model. The one I chose is yellow, the others are blue. I want them to be 1 millimeter, and let's say okay. We say okay, and now on step 187, I'm going to rename that to small edge fillet. Now, we need more fillets. Let's come up here, select fillet. I want this to be manual. And I want a multi-radius fillet, which is right here. If I scroll down to here, right here is my multi-radius fillet box, okay? So I want to click that. Now I'm selecting, okay, I have my 1 millimeter chosen for my size. Now I will select this edge. I will come over here, and I don't want that in there. So I will right mouse click on it, and if I say clear selections, it gets rid of everything. So I have to pick this again. If I have something picked that I don't want, and I want to get rid of it, I can right mouse click on it. Instead of clear selections, I can just say delete. Clear selections will get rid of all the selections that have been made inside the blue box here. delete will delete only the item that is highlighted. So that's face 1. So I will delete that. Now I have edge 1. And I want to select this one as well. Edge 1 and edge 2. And you see how they propagated all the way around. That's because we have tangent propagation selected. If I deselect that, it will do only that edge. If I select it, it will do all of the edges. All of the edges that are tangent to the edge that I chose. It won't do these holes, it will just do these outside edges. And there we are. Okay, one more thing to do on this piece. We've now done filleting, we've extruded, we've extrude cut, we've done filleting, and now we will do a hole wizard. So I'm going to check, so I'll save it again. That was good to save. Now I want to come up to the heads up view toolbar, which is right here. Right here. And that is called the heads up view toolbar. Okay. Good to know what things are called. So I come up here to the heads up view toolbar. I want to choose the back view. And I am going to create a hole wizard item. The hole wizard is up here. It looks like it's got a little wand and a spark on it right here. Anyway, that's the hole wizard. I will use that to create a countersink hole. So I will click countersink. I want that to be ANSI metric. So there's ANSI metric. I would like a socket, oval, flat. I want a flathead screw. And the size I would like, can you tell I just did this and it kept all the sizes the same, is the M4 4mm hole. Fit is normal. Other options would be close or loose. I want a normal fit and I want this to go through all. So there are two parts to a hole wizard feature. One part is determining the type of hole that you want, size, the normal or the metric or what, all those different factors as the type. And then the other portion of this is the position. So where does that hole go? Now I'm on the back surface and I want to pick the surface. So I click there and I'll click here. Now I will escape and put some dimensions in. I want this to be from this edge. I want it to be half the distance. My plate is 56 long, so I'll go 56 divided by 2. Will get me there, and I know that's 22 high, so I want to go 11 high, so I will click there and there. It doesn't matter which edge you pick first. You can pick the outside edge or the center of your hole. Either one works fine. There to here or here to there. And those are the dimensions. That gets me through step 220 on page 2-44. And here is my hole. I have the hole style, the hole type chosen, and I determined the location or position of it. So I checked the green check mark, and there's my hole. So that's what I want. Now if I display it by isometric, there it is. So what did we do on this part? We did, what were the steps? We did extrude, space, did extrude cut. Oops. That's where we sketched on the front face. We made our holes the same size, and we made the 2 holes. We made 1 hole. We copied the hole by using Control and drag. We made the holes equal. We made them horizontal, and then we positioned them, dimensioning them from the edges. And then we cut all the way through. We did a through-all cut with those holes. So we used the horizontal relations and geometric relations and linear dimensions. Other thing that we did was we made fully defined sketches, which we like. And the 4th thing that we did was we used the hole wizard. So those are the features, tools that we learned to use in creating the plate, okay? All right.